Hello, pre-calc students. Continuing on with question 5 in the conics section. When an airplane travels faster than the speed of sound, the sound waves form a cone behind the airplane. The airplane is flying parallel to the ground, and the sound waves intersect the ground in a hyperbola with the airplane directly above its center. Sonic boom is heard along a hyperbola. If you hear a sonic boom that is audible along a hyperbola with the equation x squared over 100 minus y squared over 4 equals 1, where x and y are measured in miles, what is the shortest horizontal distance you could be from the plane? And so the shortest horizontal distance, if the airplane is in the center of the hyperbola, would be right behind. So I can't draw airplanes. Just imagine this is the airplane in the center. But the shortest distance is going to be the distance from the center to a vertex of one of the parabolas in the hyperbola. And that distance we need to know is A, which is the semi-major axis. That's the distance from the center to the vertex. Now, the standard form of hyperbola is x squared over a squared minus y squared over b squared for horizontal hyperbola. And so in this case, 100 is equal to a squared, which means a is equal to 10. So the distance from the center to the vertex is 10. So the answer is 10 miles. So you just got to be able to conceptualize the problem. Moving on. For problem 6, the shape of a roller coaster loop in an amusement park can be modeled by the equation y squared over 4,225 plus x squared over 2,500 is equal to 1, where x and y are measured in feet. What is the height of the roller coaster above the ground when it reaches the top of the loop if the lower rail is 25 feet above the ground? This indicates a vertical ellipse. A vertical ellipse is the vertical distance of a vertical ellipse. And so the vertical distance of a vertical ellipse is 2a. The reason why we know this is a vertical ellipse is because the denominator is larger under the y term. So this ellipse is the formula y minus k squared over a squared plus x minus h squared over b squared is equal to 1. So we need to find the major axis length 2a, because as we're visualizing it, here is the ground, follow my cursor. Then the roller coaster loop-to-loop starts 25 feet above the ground. And then the highest point of the ellipse is going to be at the very top of the ellipse right here. So that's going to be the full major axis length. So that's going to be 2a. So 4,225 is equal to a squared. So we need to take the square root. So the square root of a squared and the square root of 4,225 is 65. So 4,200, so we take the square root of 4,225. That value is 65. So that's equal to a, but we need to find the major axis length, which is 2a. So 2 multiplied by each side by 2, making 130 equal to 2a. So our distance above the ground is 130 feet, which is the major axis of the ellipse, plus 25 feet where the ground starts. So 130 plus 25 is equal to 155 feet. So the answer choice to 6 is C. An object launched straight upward from a platform with initial velocity of 60 feet per second. The height h in feet above ground level of the object t seconds after launch is given by the function h of t is equal to negative 16t squared plus 60t plus 27. At approximately what value of t will the object have a height of 59 feet and be traveling upward? So h of t represents the height. So we need to have the projectile motion of this object. We need it when the projectile motion is equal to 59. So I'm going to create two functions in my calculator. 1 is the projectile motion of the object, negative 16. Our variable is t, but here in the calculator, the variable is x. X squared plus 60x plus 27. And this has to be equal to 59. So I'm going to change my window so that my y max is 80. So that way we can look at this, find the intersection. We can get second calc, find the intersection. The intersection is going to go up, and you have the first curve. I identify the first curve. The second curve, I'm on the second curve, and then use my best guess. So this is the approximate. This is when the object's gonna be traveling upward. So I'm gonna move my cursor to the first intersection, and the guess is gonna be 0.64359. So from our calculator, so I do use calc intersect and then you have 0.643 comma 59, and that's for the first intersection of y equals 59 and y equals negative 16t squared plus 60t plus 27. So that's going to be A, 0.64. What is the maximum height of the object launched in the previous question? So here, we're going to have to take our window, and we see we need to increase our y max. So you can take my y max to 100. All right, and now I'm going to calc maximum. I'm going to choose a left bound point and a right bound point. And we see the maximum is 1.87, 83.25. So the maximum, we're going to take the function. So we take the function. So we take, if this will draw, take the function calc max, and then we see that the maximum point is going to be 1.87, and that the maximum height is 83.25, as we can see on the calculator right here. So the answer choice to 8 is B. All right. For 9, a bridge is 100 feet across, and a parabolic dish arch over the bridge has a height of 0 feet on both ends of the bridge. The arch reaches a maximum height of 58 feet halfway across the bridge. How high is the arch? 10 feet from the center of the arch. So what we're going to do here is look and analyze this graph. One. second here. So analyzing the graph, we have a maximum point at 58 halfway across. So we have a vertex at 50, 58, because 50 is halfway across and 58 is the maximum height. So we have HK as 50, 58. And then we also know that we have a point XY 0, 100, or 0, 0. We also have a point at 100, 0. But here we need to find the parabola, where in the standard form of a vertical parabola is y is equal to 1 over 4c times x minus h squared plus k. Here the focal length is not going to be too important, but we need to find 1 over 4c. So we have a point 0, 0 and a vertex 50, 58, because we know 0, 0 is a point. So just plug it in. 0 is equal to 1 over 4c times 0 minus 50 squared plus 58. So doing some algebra, negative 58 is equal to 1 over 4c times negative 50 squared. So divide each side by negative 50 squared. And then 1 over 4c is going to be equal to negative 58 over 50 squared, which means this will be equal to negative 0.232. And that's going to be 1 over 4c. Now, what we can do, and then sorry, that's 0.0232 because we're doing the operation negative negative 58 divided by 50 squared. So this should be negative 0.0232. So this is negative 0.0232 times, and we need to find the height of the arch 10 feet from the center. Well, the center is 50. So we find the x value, so we find the height, the y, we're still solving for y, the height, when the x value is 60, minus h, 50 squared, plus 58. So this value, 60 minus 50 is 10, 10 squared is 100, so we have this value times 100, plus 58, we will get the answer 55.68. So this, plug this into the calculator, and you get the answer y is equal to 55.68. This is a conceptually part. You got to understand that you have a point on the parabola 0, 0. The vertex is 50, 58. And you're looking to find the y value of the point with an x value of 60. All right, 10. What is the range of the function f of x equals negative 4 times x plus 3 squared plus 11? So it's plotting time. We have the function negative 4 times x plus 3 squared plus 11. All right, and then we're going to make sure our window, our y max, it's not going to be as high as 100, but let's make it like about 20. And then let's graph the function. So we can see that this is the maximum value right here. We can find the maximum, choose a left bound point, so let's keep on find a left bound point right here and a right bound point right here. Make our best guess. We'll see that the maximum value is 11, so the range is from -infinity to 11. So showing a work, calc, maximum, all right, and we see that for the parabola we have a vertex at -311. You can also just analyze this function if you're comfortable with this and say this is a parabola, and we say that the vertex is at -3, switch the sign, +11. That's 10. For 11, which answer choice gives the standard form of the hyperbola given by 9x squared plus 36x equals, let's hope it loads. So 9x squared, 9x squared plus 36x equals y squared minus 10y minus 2. And so what we're doing here is we have to group the x's and the y's. And when we are grouping the x's and the y's, we are going to have we can factor out a 9, so we have 9 times x squared plus 4x, and then we subtract a y squared to get it on the other side of the equation. We add a 10y to get it on the other side of the equation, and we say that's equal to -2. Now we need to fully group together the y squared and the -10y, so we factor out a -1. When we factor out a -1, now we are subtracting positive y squared and now subtracting -10y. So you are going to change the sign so you can put the y squared term in the parentheses and then make that a -10y. And then here we are completing the square. So to complete the square, we take 4 for the x's. 4 divided by 2 is 2. 2 squared is 4. So we add 4 on the left, inside the parentheses on the left-hand side. On the right-hand side, let me zoom out. Because we're adding a 4 multiplied by a 9, we have to add a 4 multiplied by 9 as well on the right-hand side as well as the left-hand side. And we also have to add by 25 by taking that -10 divided by 2, that's -5, and -5 squared. So we're sorry, that's a -5. And -5 squared is +25. But remember, we factored out that -1, so we're really multiplying by +25 times -1. So we are adding -25. So we're doing all that work to have 9 times x plus 2 squared over 9 minus y minus 5 squared over 9. And the reason why it's over 9 is because you add -2, 9 times 4, and subtract 25, and then you're going to get 9. 36 minus 25 minus 2 is 9. Divide each side by 9, and here the 9's cancel out. You just get x plus 2 squared minus y minus 5 squared over 9 is equal to 1. And that is the answer choice B. Okay, that's 11. All right, let's keep on moving. What are the locations of the foci of the hyperbola below? So here, we got to use a Pythagorean relation. For a vertical hyperbola, the foci are h, comma, k, plus or minus c. Here, 25 is equal to a squared, 49 is equal to b squared. For hyperbola, c squared equals a squared plus b squared. C squared is equal to 25 plus 49. So c squared is equal to 74. C is equal to the square root of 74. HK, well, h, x minus 1, switch the sign, is positive 1. K, y minus k, switch the sign, is negative 6. So you have a center at 1, negative 6. And then it's k plus or minus c. C is the square root of 74. So you need to take the square root of each side. So our foci will be at 1, negative 6, plus or minus the square root of 74. So that's going to be answer choice D, and that is your Conics packet.